friends, welcome to my channel. In today's class, we'll do this isometric diagram by using the given data. Here in the given data, one cylindrical block is there. This is the cylindrical block. Okay, it has circles both sides. So on this centrally, at the center, we are keeping this square pyramid. Doing this, let us take the given data initially. Isometric diagram is three-dimensional diagram. Here a square pyramid. Square pyramid means I am taking this is the example. It has one base, it is square. Okay, square means all four sides has equal length in this case. Okay, so this square is connected to this point, it is called apex. What type of inclined surface will be there? It is a triangular shape. Okay, so here one triangular shape, here one triangular, we can call it as face also. Okay, here one triangular face, here one triangular face. So square is connected to apex by using the triangular faces. Okay, then we can call this is a pyramid. Okay, square pyramid of base side 25 mm. As I told, this is the base. Each side is 2.5 centimeter or 25 mm. Okay, and axis 40 mm. Axis means it is the height. If you are taking roughly three-dimensional diagram, okay, let us take. So this is the axis. Axis means two big lines with a dot. Okay, like this. Let us take height is 40 mm. Now we have to join, this is the apex, I am taking O. These are the triangular faces. Okay, roughly I am doing without using the instruments. This is the behind corner, we can't see, that's why I took the dotted. Roughly I did, it is a square pyramid. Okay, so height of this pyramid is, our axis is 40 mm. Axis means from the center of the square to apex, this distance is called height or axis. It is 40 mm. So if you are marking dimensional line, 40 mm or 4 centimeter. So this square pyramid we are keeping on the cylindrical block of base diameter 50 mm. So just roughly I took one cylindrical block, okay, like this. So roughly I did here. Cylinder means it has both faces have circles. Okay, and we can call this is a base and it has some height. Okay, this is a cylindrical block. We are keeping this pyramid on the cylindrical block. Okay, so like this. So centrally we are keeping, centrally means the center of this square pyramid and center of this cylindrical block coincide with each other. We are keeping this at the center of this cylindrical block. Okay, and base diameter of the cylindrical block is 50 mm. So this I have marked here. As we know, this is circular one. I am keeping this is a diameter. Okay, diameter 50 mm, and thickness means height of this cylindrical block is 20 mm. So from center of this bottom surface to center of this top surface. So this is called thickness. It is how much? 20 mm. Draw the isometric projection of the arrangement. We need to do the isometric view as it is by using the drawing instruments. Okay, so in the sheet no need to do this diagram, you roughly do in the paper, and after by using the instruments you do the diagram. So here we need to do the isometric projection. Isometric projection means here whatever values we are seeing, okay, those will be reduced in isometric view. Let us take this is the square block. Now if you are seeing like this, it is looking as it is. Whatever length will be there, same length we can see from this side. Okay, if it is tilting like this, if you are seeing like this, whatever this length, previous length, it is tilting now. So it is getting reduced. Means we are seeing the reduced one. This side also we are seeing the reduced one. How much we need to take the reduced value? In it, in engineering drawing, original value into 0.816 mm. In engineering drawing, we have to remember that value for doing the isometric projection. Okay, whatever given values will be there, we have to multiply with 0.816 mm. Okay, so here this value 40 mm height, 40 into 0.816 mm. Okay, this value, and here this value, so this is 25 mm. So we need to calculate this value also. 25 into 0.816. Okay, and here 20 mm this height, 20 into 0.816. Here 50 diameter, 50 into 0.816. Okay, so remember this value and do all these values by using the classee. So initially 40 into 0.816. How much it is? 32.64 mm. Okay, how many centimeters? 3.26 or 3.3 centimeters approximately. Okay, 3.26 means we can take 3.3 centimeters. Now here, after that, 25 into 0.816. We need to multiply all the values. Okay, so take 25 into 0.816. How much it is? 20.4 mm. So units are important here, or we can take approximately 2 centimeter. Okay, so after that, here 20 into 0.816. So it is 16.32 centimeter. Sorry. So here 16.32 mm. So we can take 1.63 centimeters. Okay. So 1.6 we can take centimeters. 1.6 centimeters. Now next 50 into this value. 50 into 0.816. This value is 40.8 mm. Or we can take in centimeter 4 centimeters. Okay, doing the isometric projection, instead of the given values we have to take the new values. We have to multiply each value by using 0.816. So here, after calculating new values, we are keeping this pyramid on the center of this surface. Okay, so this center I am taking both centers, this surface center and this center I am taking 1. Okay, this base surface center I am taking 2. This is already I have marked O. All centers are coming on the same axis like this. Okay, after that, here let us start the diagram isometric view from the bottom. Okay, so this center is 2 I am marking. Here in isometric view, whatever circular shape will be there, it is looking like ellipse. Correct? If you are taking this circle in isometric view, it is looking like ellipse. Correct? We need to do this ellipse. We need to do this isometric view. Okay, for doing it, roughly take, this is a circular one. Okay, here I will do the circle. So what is this diameter? Instead of 50, we are just now we have calculated 4 centimeter. Let us assume we did 4 centimeter radius circle. New values we have to take. Okay, here I did at the center I did horizontal diameter, vertical diameter. Okay, and I will take one box which is passing through all these points. Okay, corners of the diameter. So the circle is coming like this. Roughly I am marking. So what is the diameter? 4 centimeter. This diameter is 4. This vertical diameter is 4. So how much this side? Whatever diameter is there, same side. So it is 4 centimeter. Vertical diameter also same, 4 centimeter. Okay, so this is a square. Okay, so each side is 4 centimeter. We need to build this square box in the isometric view initially for getting this ellipse. Okay, let us do this diagram initially in the isometric view. So here I am taking roughly, so A, B, C, D corners for the square. Okay, take initially A point, capital A point here, and in isometric view give the names capital letters. I am leaving some height, so this diagram is coming. I am starting from here. Okay, in isometric view this box is coming. Roughly I am doing like this. It is coming like rhombus. Okay, initially take A point. So we can take any point here. I am taking, this is capital letter A. In isometric view we use capital letters. So here how much angle we need to take? This side 30 degrees, this side 30 degrees. Okay, let us take capital A point. Okay, here also give some gap, here also give some gap. You can't start here and the diagram is coming out of the page. Okay, so give some gap here, so it should be symmetrical. Okay, here at A do just one horizontal line like this of some length, like this. Okay, after getting this, take 30 degrees two lines by using the protractor. This side 30 degrees and this side 30 degrees. Okay, now do the lines, 30 degrees lines like this. here one line, here one line. Okay, now how much each side? Each side is, it is 4 centimeters, so mark 4 centimeter one side, make it little dark. Here also mark 4 centimeter. So on these inclined lines I am taking 4 centimeter this side, 4 centimeter this side, I am marking. So this is the A point, initially AB this side and AD this side, and after that do the DC line. DC line is parallel to AB. Okay, here we need to do DC line parallel to AB. So for getting parallel lines, take this is a reference line, move the scale at D, do the line. Okay, we will get line. Here at B also do the BC line parallel to AD. BC line parallel to AD. So take this is a reference line. I am using roller scale here. By using drafter it is easy to do the parallel lines. So fix the drafter scale to this line and move the scale like this. Okay, so the intersection point is the C point. Okay, this point. Now after getting this, mark the center. How to mark the center for the rhombus? Just join opposite ends of the rhombus. Do thin lines. So this is the center. What is the center name? We have to give 2. Okay, after giving centers, we need to do the ellipse here. Okay. For doing it, I will follow the 4 center method. In 4 center method, we need to find the 4 centers. Okay, first 2 centers are, we have to take the less diagonal length of this rhombus. So it has 2 diagonals, BD diagonal and AC diagonal. Which is a less diagonal length? In it, AC is a less diagonal length compared to this length. Okay, so 2 centers are AC. One center is A, the another center is C. Roughly I am writing here. Now after finding 2 centers, we need to find 2 more centers. Okay, it is called 4 center method. For doing it, just mark the middle points on each side of the rhombus. As we know, this is how much? 4 centimeter. Okay, this is 4 centimeter. Middle point means 2 centimeter. So this is middle point. Okay, now here mark here also middle point, like this 2 centimeter. So this is a middle point. On the same line you can mark the middle point by moving the scale. So because it is symmetrical, all sides are equal length, and this side also mark the middle point. No need to measure every time, just mark correctly and by using scale take the middle points. Okay, after that use names, any names for these middle points. Okay, I am giving PQRS. Okay, P Q R S. After getting middle points in 4 center method, initially we have to take either A or C. Okay, I am taking C point. Join this C point to opposite middle points. These are the middle points opposite to C. Okay, join C to P, join C to Q with the help of thin lines like this, and here also like this. Now take next center, A center, join this center to opposite middle points. S and R are the opposite middle point to A. So join A to S, A to R. Now here we got the intersection points. Give name, any name we can give. E, F I am giving. Okay, E, F are the next 2 centers. First 2 centers are less diagonal length points. Okay, these points AC. Next centers are E, F. Okay, so these are the centers. Okay, here roughly I did it, and we need to take the radius for doing this ellipse. Okay, if A is the center, take AS or AR radius. Okay, here I will write AS radius by using compass. AS radius, join the opposite points, middle points. Okay, like this. Next center is C center. Okay, CP or CQ radius. CP radius, take C center by using compass, join opposite points. Okay, like this. So here we got one arc, here we got one arc. Okay, after that take next center E center. ES or EP radius. So E center, ES radius. So E center, ES radius by using compass, join opposite points like this. Okay, so next center is F center, FR or FQ radius. F center, FR radius, join opposite points to this center. So here we got this ellipse as base of this entire arrangement. After getting the bottom surface, we need to take the top surface. Okay, here just do the line, axis line from 2. Okay, so axis line means 2 big lines with a dot up to some length. Okay, because axis is passing through this diagram also. After getting the axis line, okay, you can mark the center one. How much this distance? 1 to 2, 20 mm. But we are taking the new value 1.6 centimeters. From 2, take 1.6 centimeters. So this is the center here. Okay, we have to give the name 1. So it is coming here. After getting the center of this ellipse, so as we know, this ellipse and this ellipse have both same size. Okay, so for doing the ellipse, here we have followed the 4 center method. We took the 4 centers, we took the 4 radius for doing this ellipse. So for doing the ellipse here also for same size. Okay, we are taking the centers only at some distance, same distance. How much height we have to take? 1.6 centimeters. So initial center is A. Okay, from A center I am taking new center for doing the top ellipse. So how much it is? 1.6 centimeters. This surface is, entire surface is 1.6 centimeters. So from A center I am taking 1.6 centimeter. So this one I am taking. Okay, so this is the center. Same name I will give, but instead of A I am giving A1. So this is one center for the top ellipse. And then next center is C center. From C also mark C1 of 1.6 centimeter height. So here it is coming C2, this is C1. Now AC centers we have marked as A1, C1. Next center is E. So all centers, from all centers take vertical length. Okay, so take, this is the reference line. At E just do the vertical line for marking the center. On it take 1.6 centimeters. So mark this center here. What is the center name? For E I am taking E1. Similarly next center is F. At F also do the vertical line. On it mark 1.6 centimeters. So this is F1. So what are the centers? A1, C1, E1, F1. So by using these centers, we will do the ellipse here. Okay, take the same radius, AS radius. Okay, by using compass. Okay, take the new centers. Okay, here we have to do. Take A1 center, do an arc up to some length like this. Okay, this arc is parallel to this. Take the next, after A1 center, take C1 center, new center. This is a C1 center. Take the same radius. Okay, do an arc like this. Okay, approximately do some length here. Here one arc, here one arc. After getting these two arcs, we need to do the side arcs. Okay. Next center is E center, that is even center, new center. What is the radius? ES radius. ES means init ES or EP radius. Okay, both are same. So take the same radius, new center, join the arcs here. I just do arcs like this. And similarly, next radius is F radius, that is F1 radius. Join these two arcs. Just do the arcs and remove the extra arcs so that you will get the ellipse. Do here complete one ellipse, make it dark. Like this. Now here just do one horizontal line. Take this is a reference line. So one is a center, just do one horizontal line. So take these 2 points. Okay, here also already we took one horizontal line, take these 2 points. Join this point to this point, this point to this point for getting the vertical height. Okay, this is a cylindrical block in isometric view. So here we can't see this curved surface. Okay, so because this is a solid, so whatever invisible part is there, we can make it as dotted. Just make it light. After that, do the dotted line. This part we can't see. Okay, make this rhombus also light color. Now here do the dotted line. Dotted means small length lines at equal distance. Like this. Now after getting the cylindrical block, here mark this height, how much it is. Instead of 40 mm, take the new value 3.3. So from 1 take 3.3 centimeter. So this is 3.3. So this center is nothing but apex of this. We are taking O. After marking the apex, here we will do this diagram. Here this is a square pyramid. So this square is looking like rhombus, like this. Okay, roughly I am doing. So this center is 1. Okay, for doing the rhombus, initially at 1 do the axis line. Here one axis line, here one axis line. Axis line is parallel to this line. So take this is the reference line. At 1 do the line, axis line. Axis line means 2 big lines with a dot. Okay, so this axis line. Similarly, here also do the line parallel to this. After getting the axis lines like this, here we need to take this as rhombus. How much each side of the rhombus? 25 mm is we have calculated 2 cm. This is 2 cm. This is 2 cm. This is also 2. This is also 2. Okay, from center we took these lines. So how much this length? From this point to this point, half. So this is 1 cm. This is 1. On this axis also, this side 1 cm. This side 1 cm. Okay. So 1 means total 2 cm. So on the axis lines, take 1 cm this side, okay, and 1 cm this side. Here I have marked 1, here I have marked 1 cm, and on this axis line also mark 1 cm this side, 1 cm this side. Okay, these points, we got these points, okay, on the axis. So at these points also do the line parallel to this. So here this is the point, take this is the reference line of some length. Okay, similarly move the scale. At this middle point also do the line. Similarly at these points do the line parallel to this for getting the rhombus. Take this is the reference line, move the scale. on the axis line, join these two lines. Okay, similarly move the scale at this point, join these two lines. Okay, here we got the rhombus, remove the extra lines. Okay, so here we got this rhombus. This is the base of the square pyramid. Here this portion we can see, make these two lines should be dark. Okay, this line should be dark and this line should be dark. In isometric view, we will see these two lines like this. Okay, now here whatever edges are there, all four edges, we need to join these ends to the apex. Okay, here we can see this line, this slant line, this slant line. We have to join all these corners to the apex. So take, by using scale, do the line here, make a dark line, and take this corner of the rhombus, do the continuous line. It is coming on the axis line only, so make it continuous. And here from this corner to apex. Now here one more corner is there. Okay, this corner. So this corner is coinciding with this continuous line. Okay, and here these lines are not visible because it is a solid. So make this should be dotted. Make it light and do the dotted lines. On the same line, thin line, do the dotted. Similarly this side also. So it is invisible part of the square pyramid. So this portion we can't see. So here also this part we can see, the remaining part we can't see. It should be dotted. All invisible parts should be in dotted lines. The other line should be continuous. Getting the diagram, make all outline should be in dark color. Here make it, this line should come inside the curve like this. Okay, and the invisible part should be with dotted line, and mark all the given dimensions. Don't mark new dimensions, whatever given value is there in the diagram, mark the same values. Here height of this pyramid is 40 mm, it has given. Okay, and don't take new value here. And here this height between center 1 to center 2. Center 1 to center 2 20 mm. Here hamar, and this center 1 to this apex already I told 40 mm, and then this base is 50 mm diameter. So take the line parallel to this and take diameter symbol 50 mm, and this pyramid base 25 mm, it is the square. So take one square symbol small 25 mm. Okay, like that you have to mark all the given dimension. Here centers are important. This is center 2. Okay, this is center 1. Here this is center apex. This is the apex. Now this is the 3D diagram or isometric projection of the given arrangement. The drawing sheet, you have to do only this diagram. No need to do this diagram. No need to calculate here in the sheet. Whatever diagrams, whatever this side part is there, you do roughly and do this diagram here. Okay. So if you like this lecture, hit the like button, subscribe my channel and share with your friends. Thank you for watching.